All right. Over to you, Aadish.
Over to me. Okay, I thought you were gonna do some introductions.
Sure, I can do that. So, hello everyone. We have this amazing person with us here today. Aadish Jain is from Hisar. He topped the prestigious contest of Lamao last year. And he's also representing India at the IMO this year. So, and
I approve of that order of achievements, by the way.
yes, yes.
Yes.
So yeah, it's quite excited to hear him. Yeah.
Thank
He's in 12th grade. He's graduating and he'll be attending Imperial College of London. Yeah.
you. Guys, also guys, please do not call me sir. I'm not that old. Not yet. Okay, sir. Okay. Okay, so I can't. I think this is the last cause. Okay, I. Okay, sir. Okay, I think this is the last cause. Okay, bhaiya, that's better. That's better. I prefer just okay. That's fine, but okay, bhaiya is better than okay, sir. Okay, I think we can get started.
Yes.
Okay, just for my biggest, how many of you have seen modular arithmetic before? Just raise your hand in Zoom or something. Okay. It seems there are three people out of what 724 people, right? That's okay. So good. Most people haven't seen. That's fine. That's nice. For the people that have seen, I hope I can still make the class interesting for you, but I'll try my best. Okay. So let me just switch and I'll just start. Okay. So let's start with something. Okay. Let's wait. How do I? Where's the right thing? Okay. So I'm writing completely random numbers. These are definitely not like very thoughtfully chosen. It's 7, 2, 3, 0, 1 or something. Okay, do this multiplication. Just kidding. Just tell me if the answer is even or odd. By the way, you can. I would prefer if you unmute instead of using chat because it's sort of hard for me to switch to Zoom and back. So, is this even or odd?
Even.
Yes. And I hope the way you didn't give that answer by actually multiplying these out. I hope you just noticed that this number is even, it ends in a zero, and this is odd, it ends in a one. So the product has to be even. In fact, hope you'd agree that it doesn't matter which numbers I put here, as long as I can replace this completely random number with any other even number, and the answer will still be even, correct?
Yes.
And similarly, if I add something else here, let's take two small numbers, 27 times 42. Even here, if I replace this, if I replace this with any even number, I just care about the parity. Parity is whether the number is even or odd, that property is called parity. If I only care about that property of the answer, then the only thing that matters is whether these things I'm multiplying and adding are even or odd. I can replace 42 here with any other even number. I can replace 27 here with any other odd number. I can replace 7,000, 72,901 with any other odd number. And the answer would still be even, correct?
Yes.
Does everyone agree with that? Also, can other people also speak?
Yes.
Okay, they can speak at least. Yeah. So, in some sense, if I only care about the fine oddness or evenness of the final number, I only care about the oddness or evenness of the numbers on this side, right? Okay. So here's a different question. What's the last digit of this final number?
Zero.
Zero.
There is something here also. Like it's this multiplication plus this. Like brackets are here. Okay.
4.
4. Right? Does everyone agree? Once again, I don't think any of you like actually multiply these out. You just notice that like the last digit of this answer only matters on the last digits of these numbers, right? So when you multiply 27 and 42, the last digit will be just whatever the last digit of 7 times 2 is, which is 4. And in this, like the last digit of this number will just depend on these two digits, 0 and 1, and those multiply to 0. So the final digit of the answer is just 0 plus 4, which is just 4, right? Uh, so once again, you will agree like here, I can switch 27 with any number that ends in a 7, and I can switch 42 with any number that ends in a 2. And the like final digit of the answer will still be the same. Correct?
Yes.
Yeah. I'll just scroll this. Wait. Okay. So in some sense, you can say that for the like if you only okay, I'll define some notation. So going back to say odd or even, I'll say that say two numbers are equivalent, and I'll use this symbol, this equal to with 3 lines to denote equivalence. I say two numbers are equivalent if they are like both even or both odd. So 2 is equivalent to 0, it's equivalent to 4, it's equivalent to -2 because all of these are even. Similarly, -1 is the same as 1, is the same as 5, and whatever. So this symbol that I've written, this just means for now, I'll change a bit later. For now, this just means that like both sides of this are both even or both odd. Okay?
Yes.
Yes. So, and you'd agree that say what we were like talking about earlier, you can replace this number by any other even number and the answer will still be the same parity. If I have any if I want to do any calculation and I only care about like the final parity, say I have like just 14 times 29 plus 3, I want to find if the answer is even or odd. Okay. So I'll write 3 equal to's here, like 3 lines, because and if say like just want to calculate whether the final answer is like 0 or 1, because all even numbers are like equivalent to 0 and all odd numbers are equivalent to 1, right? Mm. Okay, so in some sense, I have like this replacement, like here instead of putting 3, I can also put 1, I can also put 5. This will not change the final answer because these are all the same numbers. Like these are all odd. And since I only care about the odd or evenness of the final thing, I only care about the odd or evenness here. Mhm. Similarly, I here also I can replace 29 by 1 or 3 or -1 or whatever, and I can replace 14 by well, I can just the best thing to replace it is here is 0 because the thing is we'll replace these by small numbers because that will make our life calculations easier, right?
Yes.
Yeah. Similarly, now okay, this notation will get now I'm using 3 equal to's to denote two numbers having the same last digit. Uh, I'll eventually like make this notation better. I'll make like differentiate them, but for now, just assume that for now this just means same last digit. Okay. Like I know I just said it means same parity, but bear with me. I'll introduce the full notation a bit later. Once again, if you have any expression, any like long multiplication plus the addition, not division, not division here, plus 14 plus 27 plus 420, you can replace any of these by numbers that have the same last digit. Numbers these are like equivalent to. We say once again, we say two numbers are equivalent if they have the same last digit. So this calculation, I just replace them with the numbers that have the same last digit. So 4 times 4 plus 7 plus just 0. And this is 16 plus 7, which is 23, and that's just same as 3. Like, we are only caring about the last digits. Okay?
Okay.
Yes. Okay, so what we have, like, the thing we have been intuitively doing, let's just write it down formally. So, like, we say two numbers, A and B, are same if they share the same last digit. Last. Okay. And what are we doing? We have been saying if we replace any number by like any number that has the same last digit, the answer will not change for our purposes, right? So wait, just give me a second. Okay. Yes. So, okay. So if say two numbers are equivalent, do you agree that adding the same number on both sides will not change anything? Say if A and B have the same last digit, then I add a number, the final answer still has the same last digit.
Yes.
Similarly, if say A and B are equivalent and C and D are equivalent, then I can say just add these like these are not equalities, but like congruences is what I'll call them. I can just add these together. So A and B have the same last digit, C and D have the same last digit, so their sums have the same last digit, right?
Yes.
Similarly, another thing, we notice that if you multiply something, that does not change the last digit. Like multiply on both sides. A dot, say, let's just use C equal B dot C. You can multiply both sides by the same number. This is like, no, right? If A and B have the same last digit, A times C and B times C have the same last digit. Yes. And similarly, A time 8 and like once again, C and D have the same. You can also do this. Everyone's following so far, right? If anyone has any question, just feel free to unmute and ask at any point. Okay, I'll assume everyone's following. And similarly, you like natural extent, like if you take the same power on both sides, that is still fine, right? If this ends in 1 and this ends in 1, you raise, no, 1 is a bad example. If this ends in 3 and this ends in 3, you square both of them, both will still end in a 9. You cube both of them, both will end in a 7, right? Does not. You can take powers, you can add, you can multiply. Like for all intents and purposes, this just works as a normal equality. Anything you can do with like normal equalities, you can do with these congruences, right? Okay. Okay, I'll assume everyone. Now, a question for you. This like same last digit, this kind of like seems a little bit like, okay, it's completely fine to write, but is there a more mathematical way to say it? This is perfectly fine, but okay, just can you say it in some other way? Two numbers having the same last digit. Is there some like symbols I can use to encapsulate this property?
Mod 10.
That is what I'm getting to. Like some other things. You can't just say mod 10 when I'm building up to mod 10. Right. Okay, someone said in chat, I'll check it out. Yes. So if two numbers have the same last digit, and if you subtract them, then this last digit is 0. And so it is divisible by 10. Right? Yes. Yep. So I can say that I call two numbers are the same if say like 10 divides their difference. this is the same as them having the same last digit, but oh, by the way, this like line I have drawn, this means divides. Like if I say like 3 divides say x, that means x is a multiple of 3. That's all this notation means. Okay. It's a single line, it's not 2 lines. That's just me being bad.
Sir, I have a doubt.
Yeah, go ask.
If A is congruent to B, can we safely say that A is congruent to minus B also? And
Okay. Okay. The thing is, the way I wrote it here, same last digit, it makes it seem you can, that like 4 and minus 4, like they have the same last digit, which is slightly annoying because it's like what the property you want is like if you add or subtract 10, the last digit doesn't change, right? 4, 14, 24, they all have the same last digit. But if you subtract 10, you get minus 6, which has a different last digit, right? So
okay.
unfortunately, like, and that actually breaks the properties I have written here. So what I will say, I'll I'll say that 4 and minus 6 have the same last digit, which does not actually make sense, which is why I was looking for this. Instead of using same last digit, I'll use this as a defining condition, 10 dividing their difference. Like, because if you subtract 4, like from 4, if you subtract minus 6, you get 10, which is indeed divisible by 10. So actually, I lied to you a little bit. This thing, this congruency, this actually just means, this is its definition, that they differ by a multiple of 10. It corresponds to them having the same last digit if they're both positive or they're both negative. But if one is positive, one is negative, it's slightly weird. And fun fact, this is why I did not sleep Jain mains maths. I messed this up.
I have a doubt.
Yeah.
The doubt is, what if we take fractional powers?
Ah. So for now, I am only defining this notation for integers. I have not defined anything for like 1 by 2 or something. That doesn't make sense here. Eventually, I'll explain how we can extend it here. You'll have to just wait a bit. That's a good question, but I'll get to that. Is that
Okay,
fine?
wait.
For now, this is only for integers. Okay. And also, the other thing we did above, two numbers being the same if they are like both odd or both even, we can also encapsulate it as here. Can anyone see how? Just speak up. I cannot check chat. Like I'm looking for like now, like I defined congruency earlier as like things having both being even or both being odd. Can you find like this kind of definition for this? Like something dividing something?
Can you clear a little bit more?
Okay, so like I have like been using the symbol in 2 different ways. Once I used it to mean numbers having the same last digit, and once I used it to mean both sides being even or both sides being odd, right?
Right.
So the numbers having the same last digit, I realize that more like in a different way, you can also say it as 10 dividing their difference, right? Instead of saying they have the same last digit. These are the same things. Up to like
Yes.
plus minus whatever that nonsense. Yeah. So is there some way to say like numbers having both being even or both being odd in a way like this? Say we had 10 divides a minus b here. Can you have like something else divide a minus b here to mean both like if like this should be true if both a and b are even or both a and b are odd? So,
2 divides a minus b.
yes. Yes, exactly. Perfect. So if both a and b are odd, their difference is even, so 2 divides it. If both a and b are even, their difference is even, 2 divides it. So the earlier property I can encapsulate as 2 divides a minus b. Here I can say at 10 divides a minus b. And so I'll finally get rid of the horrible notation I was using. So when I say two numbers have the same like parity, oddness and evenness, I say a and b are same mod 2. The reason I put 2 here is because when we write this property mathematically, we get 2 divides something. And when I say they have the same last digit, then I say A congruent to B mod 10, because 10 divides their difference, right? Is everyone clear what I mean by these notations now? This
Clear.
notation means both. Yeah. Everyone, it doesn't even have like any doubts. Feel free to speak.
No, nowhere.
Ask my question. Wait, how is adding two same numbers have the same last number? Wait, what? Someone asked, how is I do not understand your question, Nikhil. No, what I said was if A and B have the same last number and C and D have the same last number, then AC and BD have the same last number. Like if A ends in a 3 and B ends in a 5, like if this is 13, this is 15, and this is 23, this is, no, yeah, sorry, these are meant to be the same. 13, this is 25, and this is, no, I just made the numbers the same. So if A is 13 and B is say 33, and C is 25 and D is say 15, so C and D have the same last digit, A and B have the same. When you multiply AC, that ends in a 5. Multiply BD, that ends in a 5. That's what I was saying. Is it clear now? It's fine. It's fine. I still have to cover them. I'll, we'll get to some problems soon. That's fine. Okay. What do you say? Okay.
Bro, keep coping.
I think you're unmuted, Gaurav. Okay. And now, as you might see, I have done with now two. Now we have two here. We have 10 here. A natural question to ask is, what if I replace it with some other number? So what if I say put like 3 here? So what do you think A equal B mod 3 should mean? Can someone who like is learning this for the first time answer? What do you think? What do you think this should mean? You know, like A like congruent B mod 10. This means that 10 divides A minus B. That's how I define. Like we defined it with last digit, but now we are treating this as a definition because this is more mathematical. And similarly, A congruent B mod 2, I defined it to mean 2 divides A minus B, which is the same as saying both can be a even or both can be a odd. What do you think I should define this as? A equal B, congruent B mod 3.
Just unmute and speak up, guys.
This is because it's okay. Okay. मेरे नहीं चाहते हैं. What is the problem? Like we have defined like two notions of like congruence. One was they have the same parity, like they're both odd or they're both even, which I took to mean that 2 divides their difference. Then there was they have the same last digit, which I took to mean 10 divides their difference. Like now, like for them, I use these notations: A congruent B mod 2, A congruent B mod 10. Now I just like I ask like if I replace 2 and 10 here, what else can I like say? A congruent B mod 3. What should like this mean? Like carry over whatever pattern we have here. What do you think this should mean?
Same reminder, Sulabh.
same remainders are left divisible by 3. And you can also say this as 3 divides a minus b, right? And like that's the same as saying they have the same remainder, right? Because like the
Yes,
remainders
sir.
cancel when you subtract them, so 3 divides it. Similarly, I'll just introduce the general notation. That is just saying that a and b are same mod k. That is not how you spell right m. If k divides their difference, same as saying k leave, like a and b leave the same remainder on division by k. This is the notation I'm using. And now, as you might expect, all these properties we had earlier that we can wait, first of all, is like this notation clear? What I mean when I say a and b are the same mod k. Uh, can anyone, like, if anyone has any doubts, just like type in chat or say. You can also DM me.
Uh,
Well,
here
chat.
is A congruent B similar to
Yeah.
B congruent A.
Yes. If say k divides a minus b, then k will also divide b minus a, because like to divide means that a minus b is like a multiple of k, right? It's k times something. With some one of you found the whiteboard. That okay, it's fine. Now that means b minus a is say minus k times n, and this still means it's a multiple of k because it's k times minus n, right? So A congruent B is just the same as B congruent A, as you would expect. Okay.
Okay, wait.
Okay. Now let's all these properties that we have written. Let's now try to like prove like here we had the intuition, right? Same last digit, so we add them. We have the same last digit. Similarly, with even and odd, we have the intuition. For general, we have to like we don't have like intuitions of what that means, but we can still prove them. Say suppose okay, the first one, wait, we just proved the first one that a congruent b is same as b congruent a. Now say adding the same digit to the a congruent b, this would imply a plus c is congruent to b plus c. uh okay, can anyone see how to prove this? Just speak mod k, like every equality is say mod k from now on. So okay, what does a congruent to b mean? It means k divides a minus b, right? That's how I have defined it. Okay. And a plus c congruent to b plus c, that means k divides a plus c minus b plus c, which is just a minus b. Hence, if this is true, we can add some number to the both sides, and that's just the same thing. It still means k divides a minus b, right?
Yes.
Right, where?
Yes, sir.
Don't call me sir, please, please. It's fine. And okay, if a is congruent to b, c is congruent to d, then we have to prove a plus c is congruent to b plus d. Okay, can anyone just speak up and tell me how you'll prove this? All of these are mod k. I'm not writing it because this will be annoying. All of these assume like there's a mod k at the end.
So C minus D divides K. So A plus C minus B also divides K.
So a plus c minus b plus d. This is, are you saying like this? This is the same as this. And
Yes.
since a is same as b, c divides a minus b. Since c is like congruent to d, not same as. Wait, something. Yeah, since c is same as d, then k divides c minus d. And if you add two multiples of k, you still get a multiple of k, right? So this is true. And what about AC times BD? Like AC and BD being the same, how will you prove this? Just speak up. You are still given these. A and B are same mod, A congruent to B mod K, C congruent to D mod K. You have to prove AC congruent to BD mod K. Stay hydrated.
Don't be afraid to be wrong. It's okay. You can just pick up whatever ideas you have.
Yeah, just fine. And
So we can multiply
hmm,
C minus D into A and C minus D into B, then
C
add on top.
minus D into A and C minus D into B. And then what?
And then we can divide it by K. So this is a multiple of K. So
Wait, are you adding these two or what?
we'll be subtracting this.
Subtract them. Okay, so you subtract them. This will be, this is a multiple of K because C minus D is a multiple of K. That's correct. This will be AC. Yeah, and then what? Go on.
So then I don't know how to say that BC minus AD is also a multiple of K. I'm doing it.
Okay, okay, it's fine, it's fine. Take your time.
This is a good start, though.
Yeah.
Can we do like AC minus BD, then try to complete the factors?
AC minus I, that's a good idea. So how will you go about doing that? So we have AC minus BD. So So the issue is that like if suppose there was like AC minus BC, then we can just take C common and get A minus B, which we know is a multiple of K. But like we have B times D instead, which is annoying. How can we deal with that?
So can we also take the remainders? Like, can we expand A as equal to like KX plus T or something like that?
Sure, sure, you can do that. So say A leaves the remainder, say R1, and like we know B also leaves remainder R1, and C leaves remainder R2, and like D also leaves remainder R2, like remainder on division by K. So this means that uh, A is like I'll call this A dash times K plus R1, B dash times K plus R1. This is what you are saying, right?
Yes, sir.
Okay. C dash times K plus R2 and D dash times K plus R2, right? So AC minus BD. So you're saying just put all of these here, right?
Yes, sir.
So this is A dash K plus R1 times C dash K plus R2 dash k plus r1. Yes. So when you do the subtraction, what happens? Like when you expand everything out,
So R1 plus R2 is only the only numbers which are not divisible by k. Everything else has k, has k in it. So R1 plus R2
yes,
minus R1 plus
r1 times r2, I think you mean.
yes, R1 times R2.
It's fine. Yes, indeed. So when you expand this out, everything will have like a factor of k attached except r1, r2. Same here. So we get an r1, r2 here and r1, r2 here. Subtraction, so they cancel. And everything else has a factor of k. So this is indeed divisible by k, as you would expect. Right? Uh, does this proof make sense to everyone?
Yes, sir.
And if anyone has any doubts, you can just speak up. Okay, I assume no one has any doubts. That's fine. So the other idea that someone suggested, we can try completing the factors. That will also work actually. So what? We have AC and we have BD. Now, if we had BC here, as I said, we could be able to factor C out, right? So just subtract BC. But you obviously, no, wait, what? This is BD, this is BD, this is BD. Yeah. But you can just like not just subtract. So you also have to add BC, like minus BC plus BC. This is the same thing. And now, do you notice something? Hmm. What can you say about AC minus BC?
C common ले लो.
Yeah, okay, let's see. We can take C common. So C times A minus B. And then B like minus BD plus BC.
So you can take B common, it could be C minus D.
B common. C minus D. And look here. A minus B is a multiple of K. So C times A minus B is a multiple of K. C minus D is a multiple of K. This is a multiple of K. And so the whole thing is a multiple of K. This is also proof, right?
Yes, sir.
Yep. So, yep. So we have two proofs of why the product is same. What else did we have here? Wait, what? Where did it go? So we have like okay. So AC equal BC is just it's a special case of AC equal BD, right? Because C is equal to C. So like, C is congruent to C. So just put B equals C here. It's fine. Last thing, A to the N equal B to the N. We actually don't need to do any expansion for this. We have already proven this. Does anyone see how?
So A minus B is a multiple of K.
We have A equal what? Can you repeat? I didn't hear.
So like an is congruent to A power n is congruent to B power n because then A power n minus B power n should be divisible by K and A, and if you expand it's like A minus B. So A minus B is a multiple of K. So it's already one.
Okay, yes. I know what you're saying. That will work, but you can also see that like we have just shown that we can multiply things to congruencies together, right? If A and B are the same, C and D are the same, then you can multiply them. And AC and BD are the when I say same, I mean congruent. So we know A and B are the same. We know A and B are the same. We multiply these together. We get A square and B square are the same. We know A and B are the same. We multiply these together. We get A cube and B cube are the same. And we keep going. Does everyone see why like you don't have to do any work? It just follows from what we have proven above. Right?
Yes, sir.
Anyone has any questions once again ask? And what he was saying actually, there's also like there's also like a more direct proof. If A and B are the same, then we want to prove A to the n and minus B to the n is divisible by k, right? So this actually, there's this factoring identity which you can just apply. This is A minus B, say A to the n minus 1 plus B times A to the n minus 2 plus B squared times A to the n minus 3 plus all the way to plus B to the n minus 1. This, as you can see, like we have A square minus B square equal like A minus B times A plus B. A cube minus B cube. Let's go. A cube minus B cube is equal to A minus B times A square plus AB plus B square. And as you can see, like we start with the power of A, we decrease power of A by 1, increase power of B by 2, and keep going. And this just generalizes to all powers. A to the 4 minus B to the 4, you also have a factoring identity and so on. This is a sort of, does everyone follow what I'm saying? Okay. Let's assume so. Good. So this is you can either do the thing I did, like keep multiplying using the property above, or you can just directly say, since say A cube minus B cube has A minus B as a factor, and A minus B has K as a factor, the A cube minus B cube is divisible by K already. Okay. Okay. Okay, we have introduced all the basics of mods. If anyone has any doubts till now, then please ask. Now we'll do some slightly more interesting stuff.
Don't hesitate to speak up. If you have any questions at all, now is the perfect time.
No doubt.
Okay.
Okay, good. We know we should proceed to problems. Okay, sure. So here is now why, I have introduced all this theory. Why is it useful? Why did I spend all this time teaching you this? So let's start with something simple, but then we'll move on to an actual Olympiad problem. Okay. Say we have y square. Can this ever be 4 times some number k plus 3? Does this I'll just put x, I'll put k, that's fine. Is there any integer y that is 3, such that if you square it, it's 3 more than a multiple of 4? Is this ever possible?
No, that's not possible.
No, that's not.
Okay. And why is that?
So we can take the remainders of when we divide a number by 4, which is 0, 1, 2, 3. And then
Okay.
if we
Can you
square
repeat?
every single remainder.
Can you repeat?
So so if, for example, if y is of the form 4k plus a remainder r.
Yeah, I got it. Let's see what you're saying. That's fine. Okay. So I'll just explain what he said. So I'm saying y being 3 more than a multiple of 4, y square. This is same as me saying y square is congruent to 3 mod 4. This is the theory we built up earlier, right? Because this equation is the same as y square minus 3 is a multiple of 4, which we just defined to mean this, right? I hope everyone sees why these two things are equivalent. And what he's saying is that just take all the cases. Y can either be y is either 0 mod 4, 1 mod 4, 2 mod 4, or 3 mod 4. The reason is it has yeah, y has to leave some remainder on division by 4. It's either 0, 1, 2, or 3. So it's same as at least one of these, right?
Yes.
Yeah. And when you square 0, you get 0. When you square 1, you get 1. Square 2, you get 4, which mod 4 is the same as 0. When you square 3, you get 9. And 9 is 8 plus 1, which is 8 is a multiple of 4. That's just 1, right? So as you can see, no matter like which case y lies in, the square is always only 0 or 1. It can never be 3. Does everyone follow?
Yes.
Yeah, and someone's sir. Yeah, wait, someone said no. The no wasn't the answer to my question. That's fine. Okay. Yes. So this is one of the main, like one of the first things you'll encounter with mods is that if you have squares in an equation, you know that mod 4, they can only be 0 or 1. They can never be 3 or 2. So sometimes Olympiad problems will ask you to like prove some random equation like does not have a solution. And like some equation involving squares. We'll cover an example soon. And you'll just see that the reason for that is like it does not it's because like squares have to be 0 or 1 and the equation is somehow implying that squares are something else. So what we have just seen is that squares are nice modulo 4. Right, squares can only be 0 or 1 modulo 4. They can be nothing else. Some other things like let's take some now one simple example. What can okay, tell me what squares can be mod 3 and mod A. Like do the same thing we did. Take all like 3 cases of y in mod 3, 0, 1, 2, the 7, 8 cases of y mod 8, and write out all the squares and tell me what you get. I'll drink some more water and zero, no, 0, 1, 0, 1, 4. Yes, yes, I'm seeing some answer in chat. I'll give like a few more, some more time so everyone can try. Yeah. I yeah. So 3 is simple. 3 is like we just have 3 cases 0, 1, and 2 for y. Square 0, you get 0. Square 1, you get 1. And square 2, you get 4. And 4 is 1 plus 3. So that's just 1. So 3 is just 0 or 1. Also, another way you can like make this fast, like, okay, this is already like not that much effort. But you can also say 2 is the same as minus 1 because like they differ by 3. So, and the square of minus 1 is just 1. Like like whenever you are taking mods, you can always use negatives. Sometimes they'll be nicer, but that's fine. And mod 8 also, I think many of you have gotten the answer. I'll just see some more in chat. Yeah. Oh no, someone no, like someone DM'd me wrong answer. You 2 cannot be a square mod 8, unfortunately. I think you made an algebra error. That's fine. It's totally fine. Yeah. Yeah. Yes. So mod 8 I will not spend much time on. You can practice it, like you can try it yourself. Just take all possible 8 numbers and square them, and you'll see you can only ever get 0, 1, and 4. And just these things, these are already incredibly useful. That squares can only be 0 or 1 mod 4, 4 or 3, and only 0, 1, or 4 mod 8. Does everyone clear how we is everyone clear how we can get them? Like you can like if you didn't do the calculation, you can do them like later, but does everyone follow what we have just done?
Yes, sir.
Okay, good. Now now we'll like do an actual problem. Let me just get the screen, get my screen. Should we have oh okay, good. Let's start with this problem. Let me just get okay, I think many of you might have just tell me how many of you have seen this problem. I'll also like put another problem. Wait, do I need to make it bigger? Okay. If you don't understand the notation, don't worry, I'll explain it in a minute. But how many just raise your hand if you have seen this problem before, or just speak up. Okay. 3 people have seen this before. That's fine. Okay, 3 people is fine. I'll also like put the second problem so you can try. Okay, I think it's like 5. It's still fine. I'll put the second problem anyway. We'll. This one. Okay, so okay, first of all, like I'll just explain the notation in the first problem in case anyone is confused. So this just means like A, B, C, D, this like n to the 4, this just means the set of all like 4 natural numbers, like 1, 2, 3, 4, or like they can be same also. So this is just saying there are 4 numbers, A, B, C, D, that 4 natural numbers, such that this holds A square plus B square plus C square equal D square. And you have to find like across all possible A, B, C, D, like this equation will have a lot of solutions. Like, can anyone like give me an example solution for this equation? Just try random values. There's no art to it. Here's one. 3 square. What is it? Someone speak up. I'll write my solution with them. Oh, chat. That is screen. I've never seen the solution. 2113. Don't put the source in chat, preferably. It's fine. Like for this problem, it's fine. For later, it might not be. Okay, so a lot of people have like just by trying small numbers, you can see that like this works. 1 square plus 2 square. Oh, was there an equal? Equal 3 square. And if you like play around a bit more, you can get 3 square plus 4 square plus 12 square equal 13 square. I think that's right. But so
Can
would you
you
want to
explain?
what?
Can
Go
you
on.
explain me what does that mean? A B C D belongs to n to the power 4.
That just means that A, B, C, D are 4 natural numbers. Like the 4 here means because there are 4 of A, B, C, and D, and N means they are natural.
Okay, I got it.
So this is just saying A, B, C, D are 4 natural numbers. Okay. Yeah. So this equation, ABC, like, will have a lot of solutions. Like I just showed you 2, but like you can come up with infinitely many more. In all, like, consider all those solutions. So this solution is like 1, 2, 2, 3. This solution is 3, 4, 12, 13. So multiply all 4 numbers. Like find like it says M divides ABCD, right? So ABCD, you multiply all 4 numbers. So in this case, you get 12. In this case, you get something I don't want to calculate. It's 144 times 13. I'll leave it at that. And you'll get a lot of these possible products. It's what the question is asking is you write down all these possible products. So there's 12, there's 144 times 13, and many more. There is some number m that always divides these numbers. Like one, okay, obviously one always divides this, right? One divides 12, one divides this, one divides that, right? It also appears that like in the 2 examples we have, both are even. Like maybe there's an odd example somewhere else, but if all are even, if all somehow end up being even, then we'll have 2 divides it every time. Maybe we can also prove like 5 divides it every time. Well, it doesn't because it doesn't, but like we can find a lot of numbers that divide, like find the largest of all such numbers. That's the question. Is question clear to everyone? You write down all possible of these products and find the largest possible number that divides all of them. Yes. If anyone has doubt, If anyone has any doubts in the question, then ask. Otherwise, we'll think of how to solve it. Okay. I assume the question is clear to everyone. So, okay. So as we just like by writing down these like two things, we already noticed that it appears it like it's always even. So if we want to prove it's like always even, we have to prove it's never odd. Right. So how will we go about like what needs to happen for ABCD, the product, to be odd?
All numbers to be odd.
Yes. We want A, B, C, and D to always be odd. Now, is it possible for all A, B, and C and D to be odd?
No, that's not possible, I guess.
Okay. Because why is it not possible? Okay. So as we have just done above, we noticed that squares like worked nicely modulo 4 and modulo 8 and modulo 3. Now we want to like prove that it's like we want to talk about oddness and evenness, right? So what should we be using? Like which of these three should we be using?
Mod 4.
Mod 4. Yeah. Because the thing is if like a number is 0 or 2 mod 4, then it's even because it's 0 or 2 more than a multiple of 4. And if it's 1 or 3, then it's odd. Right. So also, so now we have this equation a square plus b square plus c square equal d square. We want to prove it's not possible for all of them to be odd. So what we do is we consider this equation mod 8. Mod 8 is also fine. In this question, mod 4 works, but in general, like mod 8 will just be better. But here I'll just use mod 4. So suppose like we want to prove these all cannot be odd, just assume for once that they are all odd, right? So if a number is odd, what is its square mod 4?
It's 3.
Is a square 3?
It's a 1 mod 4.
Yeah, it's fine. Yes, because as we just did, like the square of 1 was 1, the square of 3 was 1, and the square of 0 and 2 were 0. Right. So if A, B, C, D are all odd, then just look at this equation just in mod 4. Right. Then A square has to be 1 mod 4. B square has to be 1 mod 4. C square has to be 1 mod 4. D square has to be 1 mod 4 because they're all odd. So we get 3 equal 1 mod 4. Is this possible? Is this true?
No, that's not true.
Yep. Because 3 and 1 are just different mod 4. This cannot be true. So we have shown that if all are odd, that's just not possible. So at least one of them is even. Right? Is everyone clear with that?
Yeah, clear.
Good. So this proves that 2 always divides this. 2 always divides this product ABCD. Yep. Can we say something more? So we have shown that at least 1 is even. Can we say something better? Like any of this can be even, like not C. D can also be.
At least 2 will be even.
Yes, very good. Why?
Because when we take a square plus b square plus c square is congruent to 1 modulo 4, because d square is congruent to 1 modulo 4, and then we'll need at least two of them divided by 4. I mean even.
Yeah, I see what you're saying. Okay, but like there's a much easier way to like say this. If like suppose there was one even number and like 3 odd numbers, then like we have odd plus odd equal even, or odd plus even equal odd. Neither of which is possible. Right.
Yeah, that's what I was
Yes, I
trying
know
to
like
explain formally.
Yeah, that's fine. That's fine. It's totally. I get what you're saying. I mean, the thing is, you don't even have to look at mod 4. You can just say like you can just look at mod 2 for this. So if one is even, then at least one more thing has to be even, right? Like
Yeah, right.
because as you just said, three things cannot be odd. So like since at least two of these are even numbers, both of them will have a factor of 2. So their product will have a factor of at least like they will 4 will at least divide this product, right?
Right.
Does anyone have any doubts so far? We have. Does everyone see why 4 will always divide ABCD? If anyone has any doubts, just like speak up or DM me on Zoom.
Like
Yeah.
the down steps. So like, how did he prove? Once again, can you just explain me? How did he prove one number is always even?
One number is always even. Okay. So suppose that's not true. Suppose like all 4 numbers are odd, right?
Oh, okay, sir.
Then a square plus b square plus c square is d square, right? And
Yes, sir.
like if 2 numbers are equal, then they are also equal modulo 4. Right? Like this is just like a this is weaker than equality. So like if they're just equal, then obviously they're equal modulo 4, right?
Yes, sir.
Yeah. So we assumed all of them are odd. If you square an odd number, so an odd number can either be 1 mod 4 or 3 mod 4, right?
Yes, sir.
The square of 1 is 1. The square of 3 is 9, which is also 1 mod 4.
Okay,
Okay.
sir. Yes, sir.
So like since A, B, C, D are odd, their squares are all 1 mod 4. So we have 1. We have 1. Like A is 1, B is 1. Sorry, A square is 1, B square is 1, C square is 1, and D square is 1. But this side is now 3. This side is now 1. And this is false,
Okay, sir. So
right?
essentially, proving that one number is always divisible by 4.
No. We have proven one number is even. Like the thing is, even if A was 2 mod 4, its square would be 0 mod 4.
Okay, sir. I understand.
So we have, for now, we have just proven one number is even. We have not proven that one number is divisible by 4.
Okay, sir. Thank
Okay. Does anyone else have any doubts?
No doubts.
Yeah. So like from one number we have even to two numbers have to be even. Like because 3 odds and 1 even isn't possible. So we have at least 2 are even. So their product is at least a multiple of 4. Okay. Right? Yes. Mhm. Now we have yeah, we have proven 4 divides, but we are not yet done. We were asked to find the largest m. We don't yet know like we prove 2 divides, then we prove 4 divides. Can it be that like 8 always divides? Is that possible?
No.
Why not?
you. So parity again.
First we proved that 2 always divides ABCD, right? Then we proved 4 always divides ABCD. Can we like is there any like should we try to prove like 8 always divides? Can that work?
I think that won't work.
Yes, sir. At least two numbers should be odd or two numbers should be even.
Actually, no, like all numbers being even is a possibility. 0 plus 0 plus 0 is 0. That
But two
does not
number can be odd.
Yes, sir.
can be
Yes,
like
sir. That's yes.
they can be, but like that still like doesn't quite resolve it. Like look here, 3 square plus 4 square plus 12 square is 13 square. Two numbers are odd, two numbers are even, but their product is divisible by like 8 because 4 has two factors of 2 and 12 also has two factors of 2. It's even divisible by 16. So that doesn't actually tell us anything. It
But
tells us stuff, but like that's not enough.
8 does not divide the pair when 1, comma 2, comma 2, comma 2.
Yes, yes, yes. Indeed. The reason we cannot try to prove 8 divides ABCD is because we know ABCD can be 12 and 8 does not divide 12. So actually, we don't need to check anything else. We don't need to check like 5 or 13 or whatever because none of these divide 12. The only numbers we really need to check are factors of 12. Right. Anything else, it's futile because they don't divide 12. So they definitely don't divide everything if they don't even divide 12, right?
Okay, sir.
Does anyone see like why trying to prove 8 or 5, like any of these is like not, it won't work?
Yes, sir.
Good, good. Now, where's my, oh, I was writing on my, like, I'm using a trackpad to write and I was writing like this. I was wondering why nothing is working. The tips. Skill issue. It's okay. Yeah, so look at 12. 12 is 2 times 2 times 3. So like 4 times 3. We have already proven like 4 is always a factor of ABCD. So like the only other number that has any hopes of working is 3. The only other prime number. Right? Any other prime number that has no hopes of working. Right.
Why is
So
that we have only one hope 3? Any
uh
other prime?
thing is like the question was M needs to divide all possible ABCDs, right?
Yeah, right.
And we know one possible value of ABCD from this solution, 1 square plus 2 square plus 2 square equals 3 square. 1 times 2 times 2 times 3 is 12. Like 5 does not divide 12, 11 doesn't divide 12. So like since any prime has to divide everything and it doesn't even divide 12, then that's like
Okay,
it won't
okay,
work.
okay. Okay, I got it.
Good. So 3 is like the only other thing that like we should be checking, right? Yes. So okay, now just do an argument like we just did to prove one of the numbers must be even. Can we? I'll give you like 5 minutes, 5 minutes, and like try to prove. If you get it, like just like DM me in chat, and like after 5 minutes we'll discuss the solution.
That's not possible, I guess.
What's not possible?
3 divides ABCD.
Wait, three dividing ABCD or not dividing? What's not possible? I didn't catch that.
3 not dividing ABCD.
So you're saying not dividing is not possible. Why?
Not dividing is possible. Dividing is not possible.
Dividing is not possible.
Yeah, always dividing is not possible.
Why?
Because there is a case where if d is congruent to mod 3 and I mean d is odd and we need at least two numbers to be even and b and c even, then b and c will leave remainder 1 both, then they will leave remainder both added to 2, and a will leave remainder 0 or 1. If a leaves remainder 0, then that won't divide abcd.
No, remainder on division by what?
uh,
It's fine. Take your time.
So I think ABC is not divisible by 3.
Not divisible. Okay, why?
So if A is congruent to if the number A is congruent to 0, 1, and 2 mod 3, then A square is congruent to 0 and 1 mod 3.
Hmm.
And then say if we take cases one number is congruent to 1 mod 3,
Hmm.
and another is congruent to 0 mod 3.
No, wait. Like one number is congruent to?
1 mod 3.
Yes, so okay. And?
Another number is congruent to 0 mod 3.
Hmm.
And another number is congruent to 1 mod 3.
Sure.
Then then the next number, like I'm talking about a square, b square, and c square. So d square should be congruent to 2 mod 3.
Which is
But
not possible.
it is not possible, sir.
Yes, that does prove that like A, B, C can't be like 2 being 1 and 1 being 0. But can there be some other case?
Oh, okay, sir. I'll work on that.
Yeah.
So I mean, 1, 1, 1. I mean, that is possible, sir.
1, 1, 1 is possible. And if it's 1, 1, 1, what is D?
If it's 1, 1, 1, then the parity will be.
No, the parity is, by the way, just for odd and even. For mod 3, you just
Okay, sir.
say mod 3. That's fine.
Okay, sir. Yes, sir.
It's
If none is divisible by 3, then all is one remainder.
I didn't hear that. Can you repeat?
If we take any of the number is not divisible by 3, then all leaves 1 as a remainder.
Hmm.
Then a
Yeah.
square plus b square plus c square is congruent to 3,
Yes.
which is 0.
Yes.
Then d square is congruent to 0 mod 3, that contradicts.
Yes. Correct. Correct. Okay. So the thing is, a lot of you were like trying to prove that it's not possible. The issue with that, a modular argument doesn't actually like, well, it can tell you it's not possible, but it's usually harder. Like, if you want to prove it's not possible, the best way to do it is just give me 4 values of A, B, C, D, such that 3 does not divide them. Right. That's a perfect, like, that just proves it's not possible all the time because there's one time where it's not possible. But so proving like modular argument can work for that, but it's usually like to prove something is false, finding a counterexample is usually easier. And the thing is, we already have like 12. That's divisible by 3. So we know it's definitely is possible sometimes. And our next example, like 144 times 13, this is also divisible by 3. So like at least like this gives us some hope that maybe it's always possible. We are not certain yet, but maybe. Right. So what you should like try to do when you're like when you think it's always possible, like if you can't find a proof, then maybe there's a counterexample. But for now, our only two examples makes us think it's always possible. So you should try like something like we did here. So assume, for the sake of contradiction, that ABCD is not divisible by 3. Okay. That means 3 doesn't divide any of A, B, C, or D. That means A, B, C, and D, like, they cannot be 0 mod 3. 0 mod 3 just means that 3 divides them. So A is either 1 mod 3 or 2 mod 3, and same with B, C, and D. So their squares are all 1 mod 3. Like 2 square is 1 and 1 square is 1, right?
Yes, sir.
Yeah. So what we wrote here, A square plus B square plus C square equal D square. A, B, and C square, all three of like A square is 1, B square is 1, C square is 1, D square is 1. So we get 1 plus 1 plus 1 equal to 1 mod 3. And this 1 plus 1 plus 1 is 3, which is just 0. So 1 equals 0 mod 3, which is false. So actually, it is in fact possible for 3 to divide. It's in fact 3 must always divide, because we have shown if 3 divides none of them, then that leads to like stupid things like 0 being same as 1. Okay, does anyone have any questions on how we proved 3 divides? One of them. Like the people who like thought that it's possible that 3 doesn't divide, do you understand now like why it must divide?
Yeah, I understand that.
Yeah. Someone asked to show second question.
So, like, is this the only case? Like, should we prove any other cases?
But the thing is like taking like these kinds of cases, like 1, 0, 1, like you're right. Like if A is 1, B is 0, C is 1, then this is not possible. But now you have like a lot of other cases. You have like, what about 0, 0, 1? This is possible. And like 1, 1, 1, 0. This is possible. So like one of them being divisible by 3, there are like lots of cases. But nothing divisible by 3, there's only a single case. 1, 1, 1, 1, 1. Right.
So,
Like,
proving that the only number which is not divisible. So, if we prove that, then all the others will be all the others will
yes,
be divisible.
yes, indeed. This is the only possible bad case. Like actually it's like one, yeah. This is the only possible bad case. Every other case is good. Every other case we already have something divisible by 3.
Okay.
Right. So, does anyone have any doubts how we prove it's always divisible by 3?
What to prove now?
What to prove now? Okay. So we have proven 4 divides ABCD. That's always true, right? We have proven 3 divides ABCD. This is always true. So in
Yeah.
fact, 4 times 3, 12 always divides ABCD. Like 4 and 3 are co-prime. Like they like, yeah, right. So if it's divisible by 4 and divisible by 3, it's divisible by 12. Right. So we have proven 12 divides ABCD always. Is everyone okay with that?
Yeah, okay.
Right?
Okay. Sir.
Yes. The question asked us to find the largest m. So we have like already found that 12 divides it. Can anything bigger than 12 also work? Right? Like we have shown 12 works, but we don't know if 12 is largest yet.
So, like you said, the first case, it is 1 square plus 2 square plus 2
Yeah.
square plus 3 square. That's the bad case. So, if you just prove that, I mean, the maximum possible values must be 12.
Yes. Perfect. Perfect. We already know in one case ABCD is 12. So like nothing bigger than 12 can divide 12. So nothing bigger than 12 can be our answer. And we have shown that 12 indeed works. So 12 is our answer. Okay?
Okay.
Okay, sir.
Yes. I'll just quickly recap for someone who's asking me. So the way we'll do this, the way we did this problem is basically we like computed the first case, we saw 12. That tells us that we should be like just checking 2 and 3. Like any other prime is just bad to check. And to check 2, we actually took mod 4 because we already know that squares mod 4 behave nicely. Like they can only be 0 or 1. And in fact, like, so for now, we assume that 2 doesn't divide any of them as like for contradiction's sake. If 2 doesn't divide any of them, then the square has to be 1, mod 4. Mod 4. And we show that actually that's not possible because a square plus b square plus c square, if a, b, c are like all odd, then this is 3 mod 4 and this is 1 mod 4. So they cannot be equal. That's how we prove that at least 2 must divide. And we also then notice that if like only one of them is even and the remaining 3 are odd, that's not possible because 3 odd numbers can't add up to an even number and 1 even plus 2 odd can't be an odd number. So at least 2 of them must be even. And since 2 of them are even, 4 always divides. The person who was asking, is that clear? Why 4 divides? Okay. And for 3, we do a similar argument. We say assume not. If not, then ABC's like all the squares are 1, which once again is not possible. So 3 always divides. Since 4 and 3 always divide, 12 always divides. And nothing bigger than 12 can divide because, well, nothing bigger than 12 can divide 12. And that's the problem. That proves that M is 12.
Okay, for this type of question, at first we will
Yes.
have to um,
Hmm.
we'll have to take the smallest value to find the uh, smallest number. I mean,
Mm,
maximum number.
yes, yes. In some way, okay. Wait, I think there's some echo. Can you mute yourself? Yeah. So what's okay? I'll tell you the source of this problem. This is 2023 RMO P1. Uh, and this was my RMO. This was the first ever problem I solved in an Olympiad. So the way I did it is actually this intuition is something that like as you do more problems, and we'll give you like a P set after this problem set after this class, you'll get like familiar with like what mods to take when. So when you see squares, you'll usually like instantly like eventually as you get good, you'll just start taking mod 4 and mod 3 directly, right? So that will already tell you that like the way I did it, I just before finding the smallest case, I just took mod 4 and I saw that implies 1 must be even. And then I saw that implies 2 must be even. And then I realized, okay, squares were nice mod 4. They're also nice mod 3. So I took mod 3 and I saw that that implies 3. And that gave me 12. But after that, I couldn't do anything. So then I took the smallest case. Like you can do the other way around. The other way around is generally like better, like because that will instantly tell you should only be looking at 2 and 3. It's just that since I had done enough problems, I knew that like mod 4 and mod 3 are the nicest thing. So I just started with that. Is that fine?
Okay, I got it.
Mm, okay. Does anyone have any doubts on like how to solve this, like, how I solve this question, or like how you would like think of the solution? Okay. I assume no one. Okay. So, next, yes. Also, I'll just say it here. So as we discussed, squares are nice mod 4, mod 3, and mod 8. What about cubes? Like, if you see a cube, like in the wild, in some equation, what number should you take that equation to the mod? Like, which mods will usually work? For this,
Mod 8.
I'll mod 8. Well, let's try. What's 0 cube? It's 0. 1 cube is 1. 2 cube is 8, which is 0. 3 cube is 27, which is 24 plus 3. So that's 3. 4 cube is once again like divisible by 8. So that's 0. And 5 cube will be what? 125. 120 is divisible by 8. So that's just 5. 6 cube is 0. 7 cube is... Okay, for 7 cube, what you do actually is, 7 is same as -1, right? So you compute -1 cube, which is just -1, and which is same as 7. So 7 cube is just 7. And okay, 8 cube we don't do because we already did, yeah, 0. So mod 8, we get like all even numbers become 0, all odd numbers become 1, 3, like odd numbers can become any odd number, right?
Seven and
Yeah.
nine also.
What? 11. Okay, so you just said the answer. Okay. Yeah, the thing with so mod 8 isn't like that nice because like we have every single odd number is possible. That's like way too many cases. On the other hand, as someone said, like try, okay, I'll just leave this as like homework. This probably put as like mod 9 and mod 11. Was that it? I actually might have forgotten, but I know, no. Mod 7 also is nice.
Yeah, I was going to say mod 7.
Yeah. Yes. I'll not cover this, but okay, consider this homework. You just check all values and you'll see like mod 7, mod 9, and maybe a few other things I'm forgetting them. You'll see that like cubes give only very few possible values. Uh, like eventually as you do more problems, you'll just get familiar with like when you see squares, you should take like mod 8, mod 3, mod 4. When you see cubes, you should take a mod 7 or mod 9 or something like that. This will develop over time. But I guess a natural question to ask is what if you see like some random thing like y to the 11? What should you do then? Oh, wait. Right. I'll like, okay, is everyone clear? Like when you see squares, you take one of these. When you say cubes, you take like mod 7, mod 9, and like we'll probably put this on the first problem of the P set or something. You'll figure out what cubes are, okay? But like what about higher powers? Right. The thing is there is a way. Okay, someone has DM'd me the answer, but for 11th powers, the best number to look at is 23, which seems absolutely random. Like, why would you ever like why would you ever do this, right? Why would you like see 11th power and come up to 23? Yeah, what's a 9? This one? Yes, the reason is 23 is 2 times 11 plus 1. Like this still doesn't make sense. That's like, yes, it's connected, but why? And this is more of a, let's say, preview of some future class. There are good reasons when you see 11 to take 23. In fact, there's like when you see any random like power, prime, no, yeah, when you see any random power, there is some algorithm to find some like nice number you can use. I will not be covering that right now. That will be, it's just like a preview, but like just know that something like this exists. But for like RMO and like early easy Olympiads, you usually don't need this, like RMO and IUTM and stuff. Yeah. Someone knows what's going on. I'll explain it. This is just a pre. Like, if you don't understand this, do not worry. Because I have not really explained this. For now, all you need to know is like squares are nice mod. These things, cubes are nice mod 7 and mod 9. When will you teach that? We'll have to see. Like, it's probably like it's few classes of it. It have to be like 1 or 2 more intro NT classes. In whenever there's a class titled order/primitive roots, that's when I'll teach this, or me or like someone else. Anyway, that was just like a preview. That does not really matter. Wait, thank you. Thank you for being so patient. And okay, I'm seeing how much time we have. Do we have enough time? Okay. Before we get to maybe, I think, okay, I'll problem 2. Okay, so let's just ask some question. When you see problem 2, what mods do you think will be nice here? Yeah, I'll give problem 2 as homework, but I'll just like I'll not do it. I'll just what mods will be nice here? What do you think? 3, 3, 3. Yes. The reason for 3 is number 1, there are squares. We already know squares work good mod 3. But even better is there's just like a 9k square here, right? So mod 3, 9 is just 0. So like this entire term disappears. If you can take a mod that makes something disappear, that's obviously very nice. So indeed, mod 3 will work. And I'll give this as homework to try this problem. Just take mod 3 and see where that leads. But we'll share a piece set. I'll put it there. Okay. Let me just cover a few more properties of mods, and then we'll see how much time we have for another problem. Okay, first of all, suppose you know, say A is congruent to 5 modulo 6. Can you tell what A is modulo 3? That's correct. But wait, that's correct. Same. Yes. It's still 5, and 5 just happens to be 2. But the thing is, if like 6 divides A minus 5, right? That's what this is saying. And 3 is a factor of 6. So 3 already divides this. So if they're same mod 6, they're already same mod 3. In general, if A equal X mod like Mn, then A congruent to X mod M. Like if it's congruent some number, it's congruent any of its factors. Because once again, if Mn divides A minus X, then M definitely divides A minus X. Right. Okay. So this you can just go down a mod. And what about doing that? Say suppose you are given A is say maybe actually sure let's do this. A is 1 mod 2 and A is say 0 mod 3. Can you find out what it is mod 6? Zero. Yeah, okay. So since A is 0 mod 3, mod 6, it has to be either 0 or 3, right? But since A is 1 mod 2, it cannot be 0 because if it was 0, it would be even. Like multiple of 6 plus 0, that's even. So we get A is 3 mod 6. Right. Is everyone
Right,
clear?
that was cool.
Sorry, can you say again?
Nothing, just go ahead.
Okay, sure. So there is, like we already, like going down is clear, like it's the same number. Going up, it's like slightly different, right? 1 and 0 give 3. But in some sense, we can still go up, right? Like going down, I mean like you take a number and you find what the number was like in its factors. Given mod 6, you can find mod 3 and 2. Given mod 2 and 3, you can also find mod 6, but that's harder. Oh, wait. The class was supposed to end at 8:30. Okay. Okay, I'll just like finish this and we'll end class. I'll just finish what I was saying. Right. So, okay. But what about say this? A is 1 mod 2 and A is say 2 mod 4. Can you find what A is say mod 8? Like 2 times 4. Here we did 2 times 3, here is 2 times 4.
How it will be
It's not possible.
It's not possible. Yes, it's actually just not possible. Because if A is 1 mod 2, then A is even, A is odd. But if A is 2 mod 4, then A is even. And there are no numbers that are both even and odd. 4 and 2 are not coprime. Yes. So as you might see, like the reason this messed up, like 2 and 3, they are coprime numbers. 2 and 4, they share a factor of 2. Right. So when numbers share a factor, going up is hard. When they don't share a factor, then you can go up. Once again, this I'm just like wanted to give you a preview of this. This is something called the Chinese remainder theorem, which once again we'll cover in a different class. But like when you are given some values for A, mod 2 numbers, M and N, that are coprime, M and N, you can find what A is mod Mn if M and N are coprime. This is once like I won't be covering this today. I'm just like this like you have seen some example, right? You see how from 2 and 3 you can go up to 6, but like if they're not coprime, going up is not possible. No, not always. Right. Yeah, anyway, okay. That's just like this is something we'll do in another class. If you don't get what I said, that's totally fine. I was just giving you a taste of what else like modular arithmetic has in store. Like one thing is like something called order slash primitive roots that will tell us how to like take mods for like random powers like 11. And here something called Chinese remainder theorem, which will teach us how to like go up in mods. We'll have classes on both of these eventually, but even if you like don't get what I'm saying, don't worry. As I said, there will be like full classes. uh I think we'll like wrap up now. If just does anyone have any questions in like what we did earlier, the basic theory of mods, like squares are nice these numbers, and like the one problem we did? Any questions?
No, no questions.
No questions. Okay. So I think I'll stop sharing my screen now. I think, say, can you just, should we, is wrap up?
Yes. I
Okay.
thank you.
If
There's no more questions, then you will take a
if
pause.
anyone has like, if anyone's like not comfortable speaking, you just feel free to DM me on Discord also. I'll answer any questions. We'll probably share some preset which like covers. Okay, thank you for the kind words. I also, anyway, yes. Okay, hope you take more class. Thank you. Thank you. Okay, thank you everyone for the kind words. Once again, my Discord is just Dark Apollo 777. You can just, I mean, it's pinged in the channel on Discord. DM me if you have any questions. Okay, due to like IMO, I'll be busy for like the next 3 weeks, but after that, I'll be. So is it okay if they like DM you for questions? Okay.
Yes, also you're
Yeah.
like more than encouraged to ask the questions on the survey. There's a lot of
Yeah.
people who are
Oh yeah,
trying to
that's
help.
also that's the best place. Yeah. Ask in like one of the math channels, and someone will help. And if you don't feel comfortable like publicly asking, you can DM any one of the instructors. They'll be fine.
Yes. Thank you so much for the amazing class. It was really fun, and all the best with your rhyme things. And we hope
Okay.
I think some students already said this, but we hope to see you back again for some other class too.
Thank you. Yeah, after like August, September, I am like doing jack shit. So I'll I'll take as many classes as you want me to.
Sounds good. Sounds good. All right.
Okay.
Okay,
Yeah,
then
I'll just stay here. Like everyone, like you can feel free to leave if you have no questions.
yes, I'll just stop the recording.
Yep. Once again, stay hydrated.